Imagine a humanoid robot that doesn't just walk or wave its hands, but can eventually perform the kind of repetitive, dangerous, and physically demanding jobs that humans do every single day. Now here's the interesting part. The biggest challenge may not be the robot's face, its AI, or even its ability to walk. It could be something much smaller and much more complicated: the actuators inside its body. And Tesla has just given us a rare look at the team working on exactly that technology. In a new video, Tesla showcased members of its Optimus team and revealed glimpses of the custom actuators being developed for the humanoid robot. At first glance, these components might look like ordinary mechanical parts, but they are actually the muscles, joints, and movement system of the robot. And if Tesla really wants Optimus to become a mass-produced humanoid robot costing around $20,000 or less, these actuators could be one of the most important pieces of the entire puzzle. So today let's break down what Tesla revealed, why actuators matter so much, and why this seemingly small update could tell us a lot about where Optimus is heading. Tesla recently shared a relatively rare look inside the work being done by its Optimus team. And unlike the usual flashy demonstrations of a humanoid robot walking or performing a task, this time the focus was much more technical. The video featured interviews with members of Tesla's Optimus team, along with footage showing the custom actuators being developed for the robot. Tesla also used the video as a recruiting opportunity, encouraging engineers and technicians to join its actuators team. That might sound like a normal hiring post, but for Optimus, hiring more people specifically focused on actuators is a pretty important signal, because Tesla isn't simply trying to build a robot that can move. It wants to build a robot that can move efficiently, precisely, reliably, and at massive scale. And those are very different challenges. Tesla has repeatedly emphasized the importance of vertical integration. In simple terms, vertical integration means Tesla wants to control more of the technology itself, rather than depending entirely on outside suppliers. Tesla already follows this philosophy with electric vehicles. The company develops batteries, power electronics, software, motors, manufacturing systems, and many other components in-house or under its direct control. And now Tesla appears to be applying that same philosophy to robotics. For Optimus, that could be a major advantage, because when you're building thousands or eventually millions of robots, every component matters. A small reduction in cost can become enormous at scale, and a tiny improvement in efficiency can also become a massive advantage when multiplied across an entire robot fleet. But there's another reason this update matters. Elon Musk has repeatedly described Optimus as one of Tesla's most important future products. The basic idea is simple. Instead of using humans for repetitive, boring, or dangerous tasks, Tesla wants humanoid robots to eventually handle some of that work. Think about lifting parts, moving objects, sorting components, performing repetitive assembly operations, carrying materials from one station to another. These are exactly the kinds of jobs where a robot could potentially operate for long periods without getting tired or bored. But to do that, Optimus needs much more than artificial intelligence. It needs incredibly capable mechanical hardware. And that brings us to the actuators. So what exactly is an actuator? The easiest way to understand it is to think about your own body. Your brain decides that you want to raise your arm. Your nervous system sends signals. Your muscles contract. Your joints move, and your arm changes position. A robot needs a mechanical version of that same system. Its AI can decide what it wants to do, but something still has to physically create the movement. That's where actuators come in. An actuator converts energy into physical movement. Inside a humanoid robot, actuators can control movements in the arms, legs, torso, hands, and other joints. And Optimus is an especially challenging machine because Tesla wants it to have human-like movement. According to the information referenced in the article, Optimus is expected to use 28 structural actuators, helping the robot achieve more than 200 degrees of freedom. Now, degrees of freedom sounds complicated, but it's actually pretty easy to understand. Imagine your shoulder. Your arm can move forward, backward, sideways, and rotate. Each independent type of movement adds another degree of freedom. Now imagine doing that across an entire humanoid body. Suddenly, the robot isn't just moving a few motors. It has to coordinate hundreds of possible movements. And then there are the hands. The article notes that Optimus's hands alone have around 11 degrees of freedom. That is incredibly important, because human hands are ridiculously complicated machines. We can grip something tightly. We can pick up an egg without crushing it. We can rotate a screwdriver. We can grab a tiny screw. We can type on a keyboard, and we can perform all of these movements while constantly adjusting our grip. For a humanoid robot, reproducing that level of dexterity is extremely difficult. This is where Tesla's actuator engineering becomes especially interesting. An actuator can't simply be powerful. It needs to be small, efficient, precise, durable, and relatively inexpensive. Think about a car motor. A motor can be relatively large because the vehicle has plenty of room for it. But a humanoid robot has a very different problem. Its joints need to fit inside something that resembles a human body. That means Tesla engineers have to pack a lot of capability into a relatively small space. And there's another challenge: weight. Imagine putting extremely heavy motors inside a robot's arms and legs. The robot might become powerful, but it would also become inefficient and difficult to move. So Tesla has to find the sweet spot between power and weight. And then comes reliability. A robot working in a factory might move its arm thousands, or potentially millions of times over its operational lifetime. That means every gear, bearing, motor, sensor, and actuator has to survive an enormous amount of movement. A human can take a break. A robot doesn't necessarily need to, but the robot's hardware still experiences wear. That means actuator durability could become one of the biggest engineering challenges for Tesla. And this is exactly why the new video is more significant than it might initially appear. Tesla isn't simply working on the robot's appearance. It is working on the mechanical foundation that could determine whether Optimus becomes a useful industrial machine or remains an impressive technology demonstration. Now let's look at the bigger picture. Why does Tesla care so much about building a humanoid robot? Because if Optimus works at scale, Tesla could potentially create an entirely new business around robotics. Imagine a factory where robots aren't limited to one specific machine. Instead, you have a humanoid robot capable of walking around the facility and performing different tasks. That's important because traditional industrial robots are usually designed for specific jobs. One robot might weld, another might move a component, another might perform a particular assembly operation. But a humanoid robot is being designed around a completely different idea. Instead of rebuilding the factory around the robot could potentially adapt to the factory. That's the long-term promise. And Tesla has an interesting advantage here. The company already operates huge manufacturing facilities, so Tesla doesn't necessarily need to wait for an outside customer to figure out where humanoid robots can work. It can potentially test Optimus internally. That creates a feedback loop. Robot performs a task. Tesla collects data. Engineers identify weaknesses. Hardware gets improved. Software gets improved. Then the updated robot performs the task again. Over time, that process could accelerate development. And this is where actuators become extremely important, because better AI can't compensate for weak mechanical hardware. You could have an incredibly intelligent robot, but if its joints are too slow, too heavy, too expensive, or unreliable, the robot still won't be commercially useful. Now think about Tesla's long-term production ambitions. Musk has previously discussed the possibility of Optimus eventually being produced in enormous quantities, with a target price around $20,000 or potentially lower. That is an extremely ambitious target, and it changes the engineering problem completely. Building one amazing humanoid robot is one thing. Building 100 is another. Building 10,000 is another. But building hundreds of thousands or eventually millions is a completely different challenge. Every actuator must be manufacturable. Every component must have a supply chain. Every assembly step must be optimized. And the final cost has to make economic sense. That's why Tesla's vertical integration strategy could become so important. If Tesla can design, manufacture, test, and continuously improve key actuator systems internally, it could potentially reduce costs and speed up development. But there is still a huge amount of work ahead. Let's compare Optimus with a traditional industrial robot. A traditional factory robot is usually designed for a specific environment. It might be extremely fast and extremely precise, but move it somewhere else, and suddenly it may need a completely different setup. Optimus is attempting something different. It is designed with a human-like body, 2 arms, 2 legs, hands, a torso, and the ability to move through environments designed for humans. That means it could potentially use existing tools, workstations, shelves, doors, carts, and other infrastructure. Now compare the actuator challenge. A traditional robotic arm might have several large joints. Optimus has to distribute many compact actuators across a full body, and it has to coordinate them dynamically while walking. When a human walks, we're constantly making tiny adjustments. Our feet respond to the ground. Our knees bend. Our hips shift. Our arms move to maintain balance. Our brain handles all of this almost automatically. A humanoid robot has to recreate that behavior through sensors, software, motors, and actuators. So when you watch Optimus simply walking across a room, you're actually watching a huge amount of engineering happening underneath the surface. And that's why the actuator team may be one of the least glamorous, but most important parts of the entire Optimus project. So what should we take away from Tesla's latest Optimus update? The biggest takeaway isn't simply that Tesla showed another robot video. It's that Tesla appears to be putting serious engineering resources into the systems that will determine whether Optimus can actually become a mass-produced product. The actuators may not be as exciting as watching a humanoid robot perform a complicated task. They don't have the wow factor. They don't make viral videos on their own. But they are the mechanical muscles that allow everything else to happen. And if Tesla can make those actuators compact, powerful, efficient, reliable, and inexpensive enough for mass production, Optimus could become something much bigger than a robotics experiment. It could become a new category of Tesla product, a machine designed to work alongside humans, or potentially take over certain repetitive and dangerous tasks entirely. But there's still a massive question hanging over the entire project. Can Tesla turn an impressive humanoid robot into a reliable, affordable product that can actually operate at scale? The answer will depend on thousands of engineering decisions, and the actuator system is clearly one of them. So while the latest Tesla video might look like a simple behind-the-scenes update, there could be a much bigger story hiding inside those mechanical joints. Because sometimes, the most important part of a futuristic robot isn't the face. It isn't the AI, it's the machinery that makes the robot move. If you enjoyed this breakdown, make sure to hit the like button, share this video with someone who's fascinated by AI and robotics, and let me know in the comments. Do you think Tesla can actually make Optimus affordable enough for mass adoption? And if you want more updates on Tesla, Optimus, AI, and the future of robotics, subscribe to the channel and turn on notifications, because this robot story is only getting started.